6.3 part 2, we're going to continue with our logarithmic functions, just doing different stuff with them today. So first thing we're going to look at is our inverse properties. So by definition of the logarithm, it follows that the logarithmic function, so log base b of x, is the inverse of the exponential function. We just had b raised to the power of x. So because they're inverses, they cancel each other out. So if we had log base b of b to the power of x, the log base b and b cancel out, and just x is our answer. Same thing if we have b raised to the power of log base b, these cancel out, and just x is our answer. So the inverses undo each other, cancel each other out. But it has to be that same value. So let's look at some examples. So for A, we have to simplify. Does anybody remember what our base is if it's not given to us? So the base of a common log. Ooh, what was that?
10.
10. Awesome. Good job, Bella. 10. So if we have 10 raised to the power of log base 10, these cancel each other out, and we're just left with what? Just 4. So the 10, the big 10, the log base 10 cancel each other out, and all we're left with is the 4. Now b is a little bit different because we don't have that same number. But can we make 25 look like a 5? Can we say 25 is equal to 5 to some exponent? Yeah, what exponent would that be? 2. We could say 25 is 5 squared. So we're going to change out this 25 to be 5 squared. So this is log base 5 of 5 squared to the power of x. So we just multiply that 2 and the x together since they're both exponents. Just multiply them. And what cancels out here? Anything? The log base 5 of 5 cancels. So what are we left with? 2x. So our answer here is 2x. Oops. Just like the one before. So anything cancel out here?
8 and log 8.
The 8 and log 8. So what are we left with? Just x. What about 14?
-3.
So the log base 7 of 7 cancel out, and we're left with -3x. What about 15? So these are not the same. Can we get 64 to look like 2 to some power? Let's try it. What's 2 to the 5th power?
Well, 2 to the 4th is 16.
2 to the 5th power would be 32. So 6 power. So 2 to the 6th power gives us 64. So we're canceling out the 64, changing it to 2 to the 6th power. So this would be log base 2 of 2 to the power of 6x. So what cancels out and what are we left with? Log base 2 of 2 cancels, and we're just left with 6x. And last one, 16. So we could change this ln to be log with what base? Remember, ln is our natural log, so log with what base would give us ln? Log of e. So now we have e and log of e. That cancels, and what are we left with? 20. It's also true that E and ln are inverses of each other, so these cancel out. So if you had e to the power of ln, these just cancel out right away. So you don't even need to know that log of e is ln if you know that e and ln are inverses of each other. Any questions here? All right, next thing we're going to look at is our change of base formula. So when putting logs into the calculator, we know that our calculator can only compute a log with base 10, our common log. So you can only put log of a number, and it just automatically assumes that that base is 10. But if we have two numbers in our log, so like let's say we had log base 2 of 4, we can use this change of base formula to rearrange it so we can put it in the calculator. So whatever our little base is here, that goes on the bottom, and whatever our big number is, that goes on the top. And then we can just assume we can make this a here 10 and this a here 10. That way we can put both of these into the calculator and get some answer. So as long as the little base for both of these is the same, we can use our change of base formula, and if it's 10, we can put it in the calculator. So this is the same thing as saying log of x over log of b. So the little number goes on the bottom, the big number goes on top. And then it also works that we can do the ln of x over the ln of b. We get the same value if we use logs or ln. But you just have to stick with one. You can't do like log of x over ln of b. Just keep it consistent. So let's look at our example on the next page. So we're going to use our change of base formula. So which number goes on the top? 6. The big number goes on the top and the small number goes on the bottom. So log of 6 over log of 3. We just put both of these into the calculator and then divide. So our log of 6 would be 0.77815, and then our log of 3 is 0.477121. We divide these two together. And we get 1.63. Now remember, some calculators are smarter than others, and some calculators you'll be able to just put this whole thing in one go and click equals and get your answer. My calculator's not that smart, so I have to split it up and do it separately.
Can't you do log 6, and then whatever you get, you press divide, and do log 6?
Yep, I could do that. I think if you also use parentheses, like you could do log of 6 and then put parentheses around it and then log of 3, you'd be able to put it all in together. Alright, let's look at our next one. So which value goes on top? 5. And then 2 goes on the bottom. So if we take the log of 5 and divide it by the log of 2, I got 2.32. And then if we wanted to, we could also use the ln's here. So we could say ln of 5 over ln of 2, and we'd get the same thing, 2.32. So we'd get the same answer. All right, this brings us into graphing. So our graph of a logarithmic function is the inverse of the graph of the exponential function. So since our exponential function, when b is greater than 1, it would be a growth graph like this. We take the inverse for our log graph. So we just flip all of our x values become y values, all of our y values become x values. So we flip it along this xy axis. So anytime your base is greater than 1, your little base here in your log equation, your graph is going to have this shape, this red one here. and it never, ever, ever, ever crosses the y-axis. Never. Same thing if your b is a fraction, so if it's something in between 0 and 1, you're never going to cross the y-axis here, and it just flips its shape. It goes this way here. So these are the two different shapes that our graphs could have. The first one's when b is greater than 1, so when it's some whole number. The second one is when b is a fraction. And then our asymptote is always when x, so whatever this value is greater than 0. So when x is greater than 0. Because you can't take the log of a negative number, you also can't take the log of 0. If you put into your calculator right now, log of 0, you would get domain error. You cannot do the log of 0. So that's why we always have to put something bigger than 0 in. So let's look at our first example. We are graphing. So we want to plug in values for x, get some values for y, and plot them on our graph. So always, when graphing your logarithmic functions, you want to start by plugging in 1. We cannot plug in 0 ever because we'd get an error. So the smallest number we want to plug in is 1. And then we also want to plug in what our base is. So 3. And for these, I'm only going to make you plug in 2 numbers. So you always want to plug in 1, and you want to plug in 3. Well, not 3 for all of them, but whatever your base is. Here our base is 3. So first thing, we have log base 3 of 1. If we do our change of base formula, which number goes on top? 1. So log of 1 over log of 3. What is the log of 1? 0. What happens if we have 0 on the top of a fraction? Nope. It's just 0. It doesn't even matter what the bottom is, we get 0. So if we go to our graph, we're going to go to the right one, and we stay on 0. So that's our first point. Next, we want to plug in 3. So we have log base 3 of 3. What number goes on top? 3. And log of 3 goes on the bottom. What's log of 3 over log of 3? 1. We also could tell, since our base and our number is the same, this 3 would have the exponent of 1, so this cancels out and we'd be left with 1. So same way we did the first couple examples, when we have the same base and big number, they cancel out and we're just left with whatever the exponent is, which here it would be 1. So when we plug in 3, we get 1. So we go to the right 3 and up 1. Once we have our 2 points, you can just draw your log graph. So just remember, it's always going to have this shape or this shape the opposite way. So it's going to be one of those 2 shapes. Here we have this way because it is greater than 1. And then again, you never ever cross, bless you, the y-axis. Because if we plugged in 0 here, we'd get an error. It wouldn't work. So we're not going to cross the y-axis. Alright, we're going to skip 19 because that's just like the one we just did. So let's look at 20. We want to plug in values for x, get some values for y, and put them on our graph. Okay, so let's plug in, what should we plug in first? Let's plug in 1. And what should we plug in next? 5. We always want to plug in 5, and we always want to plug in 1, and we always want to plug in whatever our base is. So our base was 5, so we have to plug in 5. So we have log base 5 of 1. What number goes on top? 1. What's the log of 1? 0. What happens when we get 0 in the numerator? What's our answer? 0. Doesn't matter what our denominator is, we get 0. So we go the right one, stay on 0. That's our first point. Next we plug in 5. So we have log base 5 of 5. This is log of 5 over log of 5. So what would we get? 1. So we go the right 5 and up 1. Once we have our 2 points, we just draw our graph. Alright, it's 21. Last one. So we're going to plug in values for x, get some values for y, put them on our graph. So what should we plug in for x? What are the 2 numbers we want to plug in?
I would say 1/2.
1 and 1/2. We want to plug in 1 and whatever our base is. So let's plug in 1. We have the log base 1/2 of 1. So the log of 1 over the log of 1/2. What's the log of 1? 0. So when we plug in 1, we get 0. That's our first point. Next, we want to plug in 1/2. So log base 1/2 of 1/2. So it'd be log of 1/2 over log of 1/2. So what do we get? 1. So when we plug in 1/2, we get 1. So we're going to go the right 1/2 and up 1. So that's our second point. Once we have our 2 points, we can connect our dots with our line. So just be careful. Here with 2 points, it's kind of hard to see like where else you're going from here. You could go this way, this way, this way. But you just know that your ln, your log graph, always has this shape. It either has this shape or this one, depending on what your base is. If your base is bigger than 1, you're going to go in this direction. If your base is smaller than 1, you go in this direction. And you never cross the y-axis, because you can't take the log of 0 or smaller, anything less than 0.